Hi guys, today I would like to discuss Earth magnetism. Earth having its own natural magnetism, and if you observe the Earth magnetic field lines is exactly equivalent to bar magnet. So you can consider Earth behaves like a gained bar magnet. So the magnetic field is much stronger. It is spread all over the huge range in the space. So let us try to get a knowledge who tried to explain the earth magnetism. It means the origin of earth magnetism. Around 1600, William Gilbert in his book De Magnete, he first suggested that earth behaves as a bar magnet and its magnetism is due to the presence of magnetic material in its center. That could be a permanent magnet. So that was his guess. So he thought that at the center a permanent magnet is present. But right now we know that earth core is very hot, so no material do exist in the solid stage. At that temperature it just be a molten. After certain years, around 1800 centuries, so according to Sir E. Bullard and Allister, so they proposed a hypothesis. So that hypothesis is the magnetic field of earth arises due to electric currents produced by convection motion of molten iron and nickel metals. So this is some hypothesis. Yeah, we know that iron and nickel having abundant electrons, and we know that a current carrying element or a moving charge produces magnetic field. So these circular currents may cause, this is a hypothesis, so that's only as a hypothesis. So let's try to understand much more about the earth magnetism. To understand that, we need to know certain early definitions. So here you can see, first if I discuss about the earth geographic axis. What is geographic axis? The axis in which the earth rotates. The axis in which the earth rotates is known as its geographic axis. Suppose if I take this as, this is the earth geographic axis. And another thing is that magnetic axis. So if you treat earth having a bar magnet, so bar magnet having north pole and south pole, an imaginary line which passes through poles is known as magnetic axis. An imaginary line which passes through magnetic poles known as magnetic axis. So the earth axis, rotatory axis is different, and earth magnetic axis is different. So there is around an angle between that. This angle between these two axes around 11.3 degree. The angle between earth rotatory axis and earth magnetic axis around 11.3 degree. And after that, we need to know where magnetic north and where is the magnetic south. By seeing this diagram itself, you can understand by observing that magnetic field lines direction. So the magnetic field lines are going out, so this we take as magnetic south. So this is south pole and this is North Pole. So the top is North Pole, Earth magnetic North Pole, and the down is Earth magnetic South Pole. Don't be confused that we are having directions. In the directions also we used to use north and south. So this north and south, what we used to represent directions, these known as geographics. So this is particularly we call as geographic north. Geographic north and geographic south. So if I show or if we guess, the Earth magnetic north is equal to the geographic north. So the Earth magnetic south is in the same, the Earth geographic south. So if you can do the same direction in terms of the geographic, so we can represent that the geographic north and geographic south, they both are in the same way, but only the angle difference is there. Okay, I hope you got that difference between what is geographic north and what is magnetic north, and what is geographic south and what is magnetic south. And similarly here we can define about equator. So we know that at the midline is known as equator. So the same way the magnetic also having its equator, which is known as magnetic equator. So it is the great circle on the earth perpendicular to the magnetic axis. So just like earth surface perpendicular we take as earth equator, but here we take that as magnetic axis. So magnetic axis, that greatest circle that is perpendicular to the magnetic axis, that is known as magnetic equator. Okay. I hope it's clear about the earth rotatory axis and earth magnetic axis and magnetic north pole and geographic north pole and magnetic south pole and geographic south pole, and the angle difference between geographic north and magnetic north is around 11.3 degree. So after that we should know about some other. This is also same, magnetic north and magnetic south. And we need to know further planes. So till now we got it about the knowledge of the axis of rotation and magnetic axis. Now to measure magnetic field right where you sit, or right in front of your computer, or right in your room. Yeah, true. We are all in magnetic field. So that is our aim, to find the magnetic field right where you sat. So how we can find? To find that, we need to take certain help. So for that, here just see, the diagram shows that certain planes are inserted in the earth. Now if you take those two, or suppose this is magnetic axis, the green one, if you take that, oops. So this is, we take as magnetic plane. Magnetic plane. And obviously other one goes to geographic plane. Likely at the equator also you have two planes. One is geographic equator plane, another one is magnetic equator plane. And the verticals we call as that meridians. Geographical meridian and another one is magnetic meridians. And the horizontal that we call as equator, geographic equator and magnetic equator. So geographic meridian, it is the vertical plane passing through geographic north and south poles is called geographic meridian. Get it carefully. Geographic meridian, it is the vertical plane. Just you insert a plank inside that earth geographic rotatory axis. So the vertical plane passing through geographical north and south poles is known as geographic meridian. Similarly, magnetic meridian, it is the vertical plane passing through the magnetic axis, so which is known as magnetic meridian. So later I use this only terminology, geographic meridian and magnetic meridian. And we need to measure certain angles too also. I hope you got it, the two definitions or the four definitions. So one is the axis of rotations, magnetic axis and geographic axis, and another one is magnetic plane or magnetic meridian and geographic meridian, and magnetic equator and geographical equator. Now we know that a compass is very helpful to show the direction. A compass knows the direction because compass needle contains a magnetic material just like iron needle, as simple as you can say. A needle which is made up of iron and it attracts, it's a magnetic material, so obviously it's a magnetic dipole also you can call. A compass is a magnetic dipole. It's having two poles, north pole and south pole. Compass is a magnetic dipole, a permanent magnetic dipole or a permanent magnet having two poles, north pole and south pole. So this helps us to find the direction. So if this shows towards to the north, so it means that is that magnetic north direction. But when you take this compass at poles means the earth, the original poles, geographic poles. So now this horizontal compass could not help us at poles. At equator and any other surface it's okay, but when it comes to poles, since it is only shows the horizontal directions only because it is having a fixed at center. But when it comes to at poles, the same compass in different name which is known as dip needle. Dip needle is nothing but a vertical compass. Dip needle in a single words if you can say, it's a vertical compass. A dip needle is just like a compass held in vertical. Dip needle measures vertical magnetic inclination, but compass measures horizontal magnetic inclination. And it's very useful when we close or somebody is going closer to the poles, because at the poles the dip needle always shows downward directions because it's having that magnetic north downwards. So to find the exact pole location, the horizontal compass will not be helpful, but it will be much helpful with the vertical compass which is known as dip needle. Yeah, this dip needle is needed to find the magnetic field at a location where you want. See it here. Suppose if you rotate a dip needle at different locations on the Earth's surface. Catch it carefully. So if you place a dip needle at the magnetic equator, so it's just like just a compass. It is showing in the vertical direction. But when you can move to at the different locations, so do you notice the change? The magnetic needle is orienting in the direction of the magnetic field direction at that point. Now if you can change to another location, so the magnetic field line directions, so the arrow mark all the way coming from the inside. But when it comes to pole, just imagine you are having a horizontal compass and you have taken to the poles. So it won't be helpful because the needle is stuck up. One and only thing it can do, it will be rotate circularly. It cannot be lift up by itself like that, but it can show vertically. That's it. So but to measure that exactly, so this dip circle is helpful at here. So the dip circle becomes exactly straight line. So the north shows downward direction. So that is the location of the magnetic north. Not the geographic north. Here it is magnetic north. Then only it is straight perpendicular. So this is the help of the dip circle. Simple. It's a vertical compass. That point you can keep in mind. And to go ahead, we need to measure certain angles. So those angles are very new for us. So the very first one is angle of dip or magnetic inclination. So this is the angle where you measure at your location to find the magnetic field. So this angle is with respect to ground or horizontal. It is the angle which a dip needle makes with the horizontal. Suppose you are having a dip needle in your location, so just leave the dip needle and just measure what is the angle it is making with the horizontal. So that angle is known as angle of dip or magnetic inclination. So the angle made by the dip circle with the horizontal. I hope you know this shows horizontal and this shows vertical. Leave a dip circle and what is the angle it shows, that the angle here it is showing. So this is known as inclination. So inclination, after we need to know one more angle, that is known as angle of declination. So the angle of declination is an angle where the angle between the geographic meridian and the magnetic meridian planes. So the angle between geographic meridian plane and the magnetic meridian plane of where you want to measure. So that angle known as angle of declination. So these two angles which are shown at here, one is angle of inclination, the angle made by the dip circle to the horizontal known as angle of inclination. The second one is the angle between the geographic meridian and magnetic meridian. So this angle, which is known as angle of declination. So with the help of these two angles, we measure the magnetic field at a given location. So let us try to measure for a given situation. If I define magnetic declination, the angle between the geographic meridian and the magnetic meridian at a place, that point is important, which is known as magnetic declination. So that declination angle, how do we measure? So the earlier angle, inclination angle, we measure with the dip circle. The dip circle, the angle made by the dip needle or dip circle with the horizontal is known as angle of inclination. But to measure the declination, you need to take the same, either the compass or the dip circle. So it is the angle which a compass needle makes with the geographic north and south direction. So if you can see it here, so this is the vertical angles. So with the help of these vertical angles of declination and inclination, we do measure the magnetic field at a given location. So what happens if you take a dip circle at magnetic equator? At magnetic equator, so the dip circle just floats as horizontal. The needle of magnetic compass is rest horizontally at an angle of dip at magnetic equator. So when you take to the poles the same compass needle, it will be rest vertically at an angle of 90 degree. So this happens at the south pole and the north pole. So in next video, I would like to get the relation between these three elements, which is known as angle of inclination and angle of declination, and how that two angles will be help us to measure the magnetic field magnitude at a given location.